Hey everybody, it's Mr. Mott. What I want to do is kind of go through a generic version of our language unit final project for this year. First thing we wanted you to do was create a model on your own from things that you might have at home. So I just found this image of some silverware to use as an example. Obviously, you'd want to choose something a little bit different. First thing we wanted you to do is have this image here. And then we wanted you to describe these as atoms, molecules, or both. And so we'd want to recognize that the fork and the spoon here, these would be considered atoms because they are alone. And then the two knives that are overlapping each other are connected, so they would be a molecule. So I would say that I have both atoms and molecules in this model. Okay. Next, we want to say is, are we looking at in our system here? Are we looking at something that's heterogeneous or homogeneous? If you have both atoms and molecules, they have to be different from each other. Even if we had two knives connected and then a knife separate, those are different even though they're all made of knives. Atoms are inherently different than molecules. So what we're looking at is a heterogeneous grouping. Next, what we would say on a big scale, since we're heterogeneous, we're a mixture. And then whenever we have a mixture, we want to talk about what do we have a mixture of? A mixture of elements or a mixture of compounds, different compounds or different elements. So on the big scale, the spoon would be considered an element because it's made of the same thing. Same thing with our fork. And then the knives are made of the same thing. They're both made of the same thing there. So I would say I have a mixture of elements here. So we do want to specify, anytime that we have a mixture, we need to specify what type of mixture. Last thing we wanted to do is come up with a formula from this. Okay, so then if I use the first letter of the name, then I would say I've got an S for spoon. I'm going to separate the spoon from everything else using a plus symbol. I have the F for a fork. And then I have the two knives together. So knives actually start with a K. And they're together, so I'd say 2. K2. If the two knives were separate, I would put the 2 in front of the K. So that was the first slide of our language project, and that's kind of what we were looking for. The next slide said, I want you to make an ionic compound using ions that have a different charge. So to kind of keep just generic, let's say that I chose that I have the A2 plus ion and the B1 minus ion. So then as far as my picture of, so then if those are my compounds, I'd want to write down the formula for my neutral compound. So because I have different charges here, I need more than one of my negative ion so that all my negatives cancel out my positive. So it turns out that I need, my formula would be AB2 of my neutral compound because I end up needing 2 of these B minus ions so that I have a total of -2 to counteract my +2. So AB2, so my ions would be the A2 plus and the B minus ion. My formula then would be AB2, and then I would have to name my compound. Now, because I'm just making this up, I can't really come up with a name, and these are generic. They're not even real ions. But I would go to my ion chart, and I would name my compound. And what I would just want to be mindful of is that are either of these ions, do they have to have any Roman numerals? But basically, I'm going to go to my ion chart to be able to name my compound. And whatever it says when I find the A2 plus, whatever that ion actually is, I'm going to use the name that's written down on the ion chart. All right. The next slide that we had to look at was draw a nuts and bolts model of our ionic compound. So what that would look like is that on a small scale, AB2 is actually still made of ions. It's the A2 plus ion and then the B minus ion, and I have two of them. So something like that. We could do boxes, doesn't really matter. My dissolving equation would be if I took my solid and then I dissolved it in solution, I would have the A2 plus ion and I would have two of the B minus ions floating around. And on a small scale, what that would look like, if I drew that in water, would be the A2 plus ion and the B minus ion. Those are floating around in the water. So then my last slide is to choose a compound from our table of solubility that we'll know will make a precipitate. So kind of keeping this generic, again, what I would say, okay, I've got my, I know that in solution, I have my A2 plus ions and my B minus ions. And I would go to my ion chart. I need to choose another ionic compound that I know will make a precipitate from either of these ions. So I would choose my precipitate, and let's say that I choose my other solution, and let's say that my other solution was C plus and B minus. Okay. Now, no, I don't want B minus. Let's go D minus. Okay. So what would happen is that when I mix these together, in solution, I would have all of these ions. I'd have my A2 plus ion, I'd have my B minus ion, my C plus, and my D minus ion. And then I would look to see, and you sort of already know this because of you want to be able to look and see which of these ions would actually form a precipitate. And you'd look and say, do the A2 plus and the D minus ions form a precipitate, or would the B minus and the C plus? So let's say that we look on our, and so my possible ion combinations that you would write down would be the A2 plus and the D minus, and then also your other one would be the C plus and the B minus. Those would be your possible combinations, and what you would do is look on the table of solubility to see which of these two combinations is going to form a precipitate. So let's say that on our chart that A plus and D minus says I, and then C plus and B minus say S. Well, the one that says I, this is going to be our precipitate. This is going to form the solid in solution. And so then our last step would be to write the formula. Because we have A2 plus and D minus, we actually need two of the D minuses so that our charges cancel out and we make a neutral compound. So my formula would be AD2. All right. So hopefully that helps you with your language unit project. If you look back in your notes, you're going to have lots of very similar examples, and hopefully that adds some clarity to your project. All right. Thanks for watching.